Hello, ladies and gentlemen, and welcome back. Root Beer here with more of the 2015 Canadian Senior Mathematics Contest, the Csmc. We're up to question number 3, so let's have a look at what that question has to say. Okay. A 5 meter by 5 meter flat square roof receives 6 millimeters of rainfall. Okay, the first thing I'm noticing is that these units do not match up. So we'll likely have to convert either to meters or to millimeters to start making sense of some of these equations. Because you shouldn't multiply millimeters by meters, because what are you going to get? Are you going to get meters squared? Are you going to get millimeters squared? It all should be the same unit. So length should all be meters, or length should all be millimeters. We're probably going to go with millimeters, because that way we'll have less decimals. We'll have more nice integers. There's 1,000 millimeters in a meter. For those of you who happen to be watching from America who use a different unit system. So we'll have 5,000 millimeters by 5,000 millimeters and 6 millimeters of rainfall. That way we can start talking about how much rainfall, so how the volume of water. So millimeters cubed would be our units for volume there. Okay, well, let's get back to the question. That's just something I noticed right off the bat. Got to remember to convert my units. All of this water, and no other water, drains into an empty rain barrel. The rain barrel is in the shape of a cylinder, okay, with a diameter of 0.5 meters, so that would be 500 millimeters, and a height of 1 meter, or 1,000 millimeters, milli being the prefix for 1,000th. Rounded to the nearest tenth of a percent, what percentage of the barrel will be full of water? Okay. So we're talking about percent. They're not asking you, how many millimeters high the water will be filled in the barrel, or anything like that. What can we do here? Well, for this question, we should probably figure out. We're given the volume of the rainfall. We can compute that because we've got a square roof, and the water fills to so high. So it's sort of like filling up a box. And we know the length, the width, and the height, so we can figure out how much volume of rainfall there is. Then we have to translate that into being to filling up a barrel. Okay, and then from there we can say, well, the volume of the rain, the volume of the rain over the total volume of the barrel times 100%. That should give us the percent of the barrel being full of water, and we want to round to the nearest tenth. Okay. So we've got ourselves a plan of attack. Let's get to it. Get some calculations. So first, I'm going to convert everything to millimeters. Okay. So 5 meters is 5,000 millimeters. We also saw 0.5 meters. This is going to be 500 millimeters, and we saw 1 meter. So that's going to be 1,000 millimeters. Okay, so we converted our units, very important. So now we can start talking about everything in terms of the volumes will be millimeters cubed. So how much rainfall is there? Well, that's going to be 5 meters by 5 meters by 6 millimeters. But that's 5,000 by 5,000 by 6 millimeters cubed, and we can calculate this out. So we've got 5,000 times 5,000, just grabbing my calculator, times 6, we get 150 million. 5 times 5 is 25, times 6 is 150, and then the other zeros come along for the ride. Okay. If we wanted this in meters, we would divide by 1,000 3 times, because we got cubed, so we'd get something like 0.15 meters cubed, I guess. So you could do the whole problem in meters, I guess. Now, the percent that we want, that's what we want. The percent is volume of rainfall over the total volume of the barrel. The volume of the barrel represents 100%. Okay. So we know the volume of the rainfall. Now we just need to know the volume of the barrel. Divide those two and multiply it by 100%, and we're going to get our answer. So, the volume of the barrel. Well, the barrel, we were told, is cylindrically shaped, and it's got a diameter of 0.5 meters and a height of 1 meter. Well, the only formula I can remember for volume of a cylinder, and we want volume of a cylinder, is pi r squared, the base, times the height. Now, I don't have r, I have the diameter. So I need to get the radius first. Well, the radius is just the diameter, which is 500 millimeters, divided by 2. So we square that, times the height, that's 1,000 millimeters, and all of this will also be in millimeters cubed. Okay, and it's this pi here that introduces the fact that we're going to have to round. So pi 500 divided by 2, we're going to have a radius of 250 millimeters. Okay, and well, I'll grab my calculator and we'll finish this calculation over on the other side. So 250 squared times 1,000, we're going to have 62,500,000 times pi. Okay. So the percent, if we remember that formula, it's going to be the volume of the rain, which we said was 150 million, over the volume of the barrel, 62,500,000 pi. And then we want to multiply that by 100%. And I think it said nearest tenth of a percent. I think that was the nearest tenth of a percent. Okay. Well, to make this a little easier on myself, I can notice that I got 5 zeros down here, and that can cancel with 5 zeros up here. 1,500 divided by 625 has got to be, it's 2.4. So 1,500 divided by 625, that's 2.4. So really this is 2.4 divided by pi. We still have this pi here, times 100%. So that makes it a lot easier, canceling out at least the zeros. So 2.4 divided by pi, I get about 0.7639. $0.76394337 is what I've got on my calculator here. Multiply it by 100%. The percent we treat as a unit, so it's going to stay here. And everything just gets shifted over 2 decimal places. So 76.394, let's say. But we want to round to the nearest tenth. Okay. Well, this 9 here means that we're going to round up to 76.4%, and that's going to be our final answer. I'll just make a little note of this. Round up. Okay. But that's going to be our final answer. 76.4% is basically how much rainfall is filling up this rain barrel that we've got here. Okay. So that was question number 3 on the senior paper. In the next video, we're going to take a look at question number 4. If you haven't already, download a copy of this contest by clicking the link in the description. Feel free to like or whatever you want to do, subscribe, that sort of stuff. But either way, question 4 coming up in the next video, and I'll see you then.